I'm super excited to share a major upgrade I've made to my shop. I've recently partnered with American Green Lights to enhance my lighting setup. This upgrade has been a game changer for visibility and color accuracy, and I'm going to take you through the entire process. Before the upgrade, I faced a lot of challenges with my old lighting. Lights were not very powerful and kind of orangey, and they didn't really provide enough brightness for detailed work. I often had to use this ridiculous headlamp just to make sure that I didn't miss any spots while sanding or applying finish. It was frustrating and inefficient. The old lights also had poor color rendering, which meant it was difficult to see and photograph things like they were supposed to be. So I spent too much time going back and forth with clients to settle on specific finishes. The lights just didn't do a good job of reflecting what the pieces really looked like in real life.
One of the best parts about working with American Green Lights is their free simulation service for woodworkers. I only had to provide a few pictures and the layout of my shop, and they helped us plan the whole lighting layouts to ensure even light distribution and optimal light levels exactly where we needed them. They even helped me prioritize which lights to install first, which was especially helpful as I'm setting up the whole shop. They also provided a cost-effective solution using retrofit kits instead of entirely new fixtures, so that helped me save a lot of money as well.
Now let's briefly talk about temperature and color rendering index, or CRI. Color temperature is essentially the color of the light. As you can see on the scale, the lower the temperature, the more red the light appears, and the higher the number, the bluer it looks. My old lights were 3500K, which in part explains why it was so orangey. We chose 5000K for my shop, which is ideal for high visibility needs like workshops, labs, kitchens, and manufacturing. To explain CRI, it's helpful to remember this picture. No, this is not the dark side of the moon. There is no dark side of the moon, but that's not the point of this. This is a prism, which basically refracts white light into all different colors in the visible spectrum, like the rainbow colors. That works well if the source of light is like the sun. So, in other words, with the sun, you're able to see all lights in the spectrum, so we say the sunlight has a CRI of 100. Now, if you replace the sun with a cheap LED light with a CRI of 85, for example, which is similar to my old lights, there's a dominance of green wavelengths and smaller peaks of orange and yellow. So these colors dominate and objects do not appear like they're supposed to. The lights I acquired from American Green Lights have a CRI of 95, which is pretty close to the sunlight, and as you can see, every wavelength is present and a significant strength, which makes everything appear very accurately. Now, this is all really cool, but there are tangible benefits for woodworkers. The fact that you can accurately see colors enable you to make the best decisions on behalf of yourself, your client, your wife, whoever you're building this to, in terms of wood species and wood finishes. The other really cool benefit about this is the fact that if you're a videographer or a photographer, or if you're taking pictures of your products, it's important that you actually have them represented accurately so that you don't have to do a lot of work in post-production in terms of color correction. The installation process was pretty easy. After ordering, the kits arrived in a few days and I got surprised at first because I was expecting a larger box considering how much light was going to be added. I guess technology advanced so much that a small thing picks up a lot of power. So I took it to my shop, but yeah, I had to let Bella in. I think she saw the box and knew there would be something fun there. I opened the box, checked everything to make sure nothing was missing, and it was all there. That little tube had 24 retrofit light strips, there were 5 LED drivers, and a box with 10 wing strips. I think even Bella liked it.
Bella?
The area I decided to install first is the area under the mezzanine, which was really dark, as you can see. So I had to open both garage doors to get some natural light in. I then ripped a couple of strips of cedar on my table saw and pre-drilled some countersunk holes into them. And with the help of my friend João, we started to hook those strips to the joists, making sure to maintain even spacing from the wall and from the end of the mezzanine. After the cedar strips were attached, it was really easy to just peel the adhesive from the back and screw the light strips with the 2 provided screws. The next step was to initiate the electrical connections, so I first installed a couple of blocks of wood to serve as spacers, since it's recommended the drivers over 150 watts be mounted to a standoff to allow for extra cooling. These drivers came with a dimming option, which I wasn't going to use, so I just kept them off with the Wago connector and took them away with a wire clamp. Next, I needed to drill some holes through the joists so that the AC cables could be attached to the existing wires. Then I attached the simple junction box, getting it ready to connect with the Romex cable at the end. And from the DC side of the driver, I also drilled a hole through the joists and the smaller junction box. This will serve as the ending that will connect the bus wire to all the fixtures. Then it was a lot of drilling. This time I needed to have a path for the bus wire to go through. I was a little intrigued at first because the wire that we used for this was an 18 gauge red and black wire. It's super interesting because I would never have guessed that so much light power could be fed by such a thin wire. But this was a low voltage, low amperage solution, so that was more than enough. The connections to the fixtures were made with this little Scotch-Lock 905 connectors, and I'll leave a link to those in the description. It was my first time using them, and someone more experienced on these will likely notice my lack of dexterity in attaching the first one, but I think I got the hang of it at the end. The idea is that you place the bus wire on one side and the lead wires coming from the fixtures on the other side. I connected the gray wire to the red and the white wire to the black. And then I used a plier to crimp the metal tab into the connector to pierce the insulation of both wires. And then you just lock it in place. To finalize the DC side of the installation, I stripped the bus wire, used a couple of Wago connectors to connect them to the driver wires, tucked them into the small junction box, and that side was done. You don't actually need a junction box for the DC side, but I thought it would look better that way. Now it was time to connect the installation to AC power. The great thing about this solution is that LED requires really low amperage. So using the same Romex cables that were previously installed is more than sufficient. Again, I used Wago connectors to join the Romex cable to the wires from the driver, tucked them nicely into the junction box, closed it, and the lights under the mezzanine were all done. Look at that. I'll show a before and after comparison at the end of the video. Now for the big lights retrofit. Because my shop has pretty high ceilings, I needed to get this 12-foot ladder in there, which you don't have me carry inside. The center line in the shop is 21 feet high and the walls are 14 feet, so investing on this A-type ladder was a good idea. I'm not gonna lie, I was a bit apprehensive about this part because I didn't really know what to expect when I took that diffuser off. And to my surprise, the lights that were installed there before were also LED, but just one strip on either side of the ballast, as opposed to 6 total that I was going to install per fixture. So I thought, okay, I can do that. I took the ballast off and disconnected all the wires. Of course, I had the power to the shop turned off at the panel. By the way, I'm pretty confident about working with electricity, especially these simple tasks like this, but if you're not, I do recommend you talk to an electrician. Once I had the fixture on my bench, I removed the old LED strips and the driver and prepared the surface to attach the new strips by cleaning it with some denatured alcohol and started adding the strips one by one. They come with this pretty strong adhesive on the back, so I just had to start from one end, peeling it off little by little and applying some pressure with my hands to secure it in place. Then I used the little holes from the fixtures to route the lead wires from the strips, which helped ensure the whole thing was somewhat organized. Next, I attached the driver to the center of the fixture, making sure that the DC wires were on the same side of the lead wires coming from the strips. I used the same screws from the old driver, but you can use some metal tapping screws here as well. On these I also kept the dim wires, I wasn't going to use that option. Now this was kind of a satisfying part because I got to use this 8-port wire connectors, which were very great for small gauge wires like this. It's as easy as stripping the wires, popping them in there, and lower the little lever to lock them in place. You can also use wire nuts in here, but I thought this would be more secure. I'm gonna spare you from seeing the whole thing, but I also took some time to organize those cables with some cable ties. The connection to the AC side was gonna happen while I was installing the lights up on the ladder, so you won't be able to see that, but really, the only thing different from this to the mezzanine lights was that even though there was a ground wire coming from my panel, these fixtures were metal, so I needed to add a pigtail wire connected to the carcass and to the ground side of the wires to ensure proper grounding. I added Wago connectors to all of the wires coming from the driver and organized them a bit with cable ties. And the fixtures were ready. All that was remaining for me to do was to attach them back onto the beams, bring the Romex cables in, and connect them to the AC side of the driver. And then finally just replace the diffuser. And it was done. Now let's look at a before and after comparison, and for consistency we've set the camera to 5000K daylight, white balance and locked exposure. As you can see, the difference is night and day. I'm really happy about how everything turned out. The new setup has 4 times more wattage and 4 times more lumens than the old one, significantly increasing the brightness. This makes a huge difference in visibility and reduces eye strain, allowing me to work more efficiently and accurately. And look at the final results. The shop is now brighter, the light quality is incredible, it's made a huge difference in my work. And for all my viewers, American Green Lights has offered a special discount code. Use code Fantin for 10% off your purchase. I think it was worth the investment. Thanks for watching, and I'll see you on the next one.